Today we were yesterday we talked about translating parabolas. And today we're going to talk a little bit about kind of the universality of translating all functions. Um, so if we look at this, this is an absolute value function here, right? As we know, absolute value is the distance from zero. And so the absolute value, for example, here, the absolute value of 2 is 2. The absolute value of 4 is 4, and so on and so forth, right? As we look at the equation, that's what this looks like. Y equals the absolute value of x minus 1. This is on the outside, right? And so that means that it's going to affect the y, just like we learned yesterday, and it's going to move it down 1. So if you just move it down 1, you can see that vertex is just dropped down. This one is inside, and since it's -5, that means it's going to move to the right 5 units. So you just click on it, move it over 5 units. Once again, to show work on this, you can just write down this original equation and then write down next to it, right 5. That's about it. So we're going to look at a couple different types of functions maybe. This one has multiple translations. This one has inside is 4 units to the right, and then outside is down 3. So we're going to go down 3 like that. And then I've translated that function. But once again, this is an absolute value function. Let's kind of move along a little bit. Now, it doesn't matter where it starts. So this is the graph of f of x is shown. And here's what they want us to do. They want us to move it, and it's +3 on the inside. That means it's going to change the x value, and it's going to do the opposite of what you think. So in other words, it's going to move to the left 3. So I'm going to move it to the left 1, 2, 3. And we don't need to know what the equation is that goes along with it. We just need to know that it needs to move to the left 3. Here's the graph of g of x, which would be an absolute value graph. But they want you to take this one and move it up 5 right there. So I'm just going to take it and move it up 5. And it just kind of speaks to the universality of all this. Let's kind of move along a little bit. Once again, some more same type of functions. This one we're going to move up 4. This one we're going to move to the right 2. Let's see what else we got here. All right. Now, we're going to play around a little bit with having an M today, where we're stretching things vertically, okay? And probably the easiest way to do this is just like we did it yesterday, where we're going to start with the vertex, right? So in this case, my vertex is +5, 3. So I'll graph that point, +5, +3. And then I'm going to start plugging in values on either side of that equation. My tools aren't working, so I'll just have to do it out loud. So I'm going to plug in 6 because that's 1 away, and then I'm going to plug in a value 2 away. So 6 minus 5 is 1. 1 squared is 1. Times 2 is 2. Plus 3 is 5. So I plugged in a 6, and I got out a 5. That goes right there. And now that also tells me this point. If you don't believe me, I can plug in a 4, right? So 4 minus 5 is -1. -1 squared is +1. Times 2 is 2. Plus 5 plus 3 is 5. Now let's plug in 1, 2 away. So that was 1 away on both sides. Now let's plug in 1, 2 away on both sides. 7. 7 minus 5 is 2. 2 squared is 4. Times 2 is 8. Plus 3 is 11. So I plugged in a 7, and I got out an 11. And once again, that's all really good work to do. And then we can push the graphy poo button, and you can see that gives us a really nice parabola. Let's see how we did. Yes! Let's see if there's another one like that. Now, this is a square root function, as you can see here. And they want us to move it. We've got 2 different translations. x plus 1 plus 2, right? So we've got plus 1 on the inside. It's underneath the bar, so that's inside the function. And this 2 is on the outside of the function. So this is to the left 1 and up 2. So I'm going to move that to the left 1 and up 2. Let's see how I did. Oh, look at that. I do have those. Okay. Now, let's keep looking and see what we got here. Once again, the universality of this. Here's a cubic function, okay, where my vertex, right now, it's also based at 0, 0, just like all the other ones we've been doing. This one says move to the right 3 and up 1. So we're going to go to the right 3 and up 1. Let's see how I did. Answered incorrect. Oh, down 1. Now recheck. Woo, that was embarrassing. Here we go. I want to see if I can find one of the harder ones. This one's straight out of yesterday, right? My vertex is at 2, 0, negative 2. And then I can plug in values around that. So let's plug in 1. 1 squared is 1, times 2 is 2, minus 2 is 0. That tells me these 2 points. 2 squared is 4, times 2 is 8, minus 2 is 6. So there goes those 2 points. Let's see how that looks. Pretty good. Check. Awesome. Now, the one thing that's kind of subtle about this is this negative sign out front. Anytime we have that negative sign, the function is actually going to be facing down. But still, we go through the same process where we go to the vertex, right, which in this case is going to be negative 2, negative 5, and then we plug in some values around it. So negative 2, negative 5. Okay. And then I'm going to plug in a value around it. So negative 1. Cool. So as we look at this one, if I plug in negative 1, right, because that's 1 away from my vertex, okay? If I plug in negative 1 plus 2 is 1, squared is 1, times negative, and the opposite of that is negative 1, and negative 1 minus 5 is negative 6. So I plugged in negative 1, and I got out negative 6, and so I can graph that point. And that also tells me this point, okay? And then I've got 0, and then I can plug in 0 because that's 2 away. And plug in 0. 0 plus 2 is 2. Squared is 4. Negative 4 minus 5 equals negative 9. So I can graph that point, and that tells me this point as well. And there we go. Let's see if there's anything else interesting in here. Let's get rid of all this, I guess. So, but it all starts with the same thing about the universality of translations. And then we're going to be kind of stretching things a little bit and just kind of taking things one step further. Let me check the rest of these here. Okay, this one's a little bit different. So as we look at this function, these two functions, the blue one is the original parent function, and the red one is the translated version that they want us to write the equation of, right? Now, this is a parabola, okay? So we know that that is an x squared function, okay? And it's been shifted up to the right 3 and up 2. So in order to write that function, I can just say x minus 3 squared plus 2. And that's all they want you to do is just look at the original and then shift it. Cool. Let's see if there's anything else. So this is an absolute value. You can tell by the V, right? And so I'm going to start by doing my absolute value bars here. And then it's shifted to the right 2. So I'm going to put an x minus 2 on the inside. And then it's up 4. And so I put plus 4 on the outside. Let's see how I did. Let's see if we got any more funky ones. Square root of x, right? And if you're wondering, you can see it right there. Okay. So I'm just going to use this square root sign right here. And then it's to the right 3. So x minus 3. And then I move outside the function and say plus 4. Anyway, well, that's it for today. And hopefully this will help